Hi everyone. Good morning, good afternoon, whatever time that you are accessing this video. I appreciate your flexibility with this lecture being online, and in all actuality, this is probably one of the best lectures for you to have online just because it might need a couple of revisiting. Some of the topics here might be a bit new to a lot of us, or it might be a review from some of the things that we learned in high school, but we're going over research in kinesiology. Your assigned reading this week were the online articles, basically just giving you a taste of what research articles look like and kind of what's expected of you moving forward after this class into your upper division classes that really require you to have a good understanding of how to read academic articles. And so I like this to be the slide to preface really what this whole research thing is about. And I like the idea that, research is always evolving, right? It's never coming to a place where what you find is the absolute truth and there's nothing else that can ever be learned in the future. There's always more room to grow in terms of kin, especially as it is a relatively young specialty that we are finding that the science is always going to evolve. And so I like this quote that anyone who uses the words prove, and proven in their discussion of science is not a real scientist. And again, that acknowledges that there's so much more room to grow and see things from different perspectives, or with time, or with technology, or with the evolution of ideas and sciences. And so I like there is no such thing as proven. There is only, support for what the current knowledge is in a certain subject. And so I like to, again, preface this with the lecture of research, as well as kind of reintroducing us to the scientific method, right? In which a lot of us maybe think of it as a linear experience where you have, again, this hypotheses and questions, then you experiment, then you collect your data, then you reach conclusions. And then that's it, right? But it's ever evolving and it's always in a cycle as opposed to a linear relationship. So researching and observing, asking questions about things. And then when you do your experiment, you find stuff that maybe you didn't think that you would find. And then that comes to certain conclusions that lead you to other observations. So again, things are ever evolving. And the point of this lecture is to really figure out how to find these things out. And again, kin is one of those specialties that is always going to continue to evolve. And so some of the things that I'm noticing from paper 3, as I'm grading them, that, again, some of the most common errors for paper 3 that we are going to talk about today is, one, we're not having incorrect text citations. And again, we're going to learn how to do that today. Similarly, an incorrect reference page. And one of the biggest gripes that I think I have, and I think that's a difference from MLA that maybe we learned a lot in high school, to APA, which is more of the standard for kin and all the sciences, is that you have to paraphrase. Even if you take something from someone else, you still have to paraphrase, and you still have to give them credit for that paraphrasing. So do not use entire quotes going forward. I will ding you for that. I do know that this was kind of an experiment for you to kind of just feel out what research was like in college. But moving forward, you do have to paraphrase and cite still. And then the last point is that you didn't include in-text citations, right? Sometimes you would say stuff that wouldn't be considered common knowledge. And so at that point, you do need to have a citation. At that point, you also need to research something that supports your arguments. So as a rule of thumb, if you say something that isn't considered common knowledge, that someone on the street wouldn't know as something that's generally understandable or generally considered common knowledge, you do have to cite that, and you do actually have to research something that supports your arguments for said part of your paper. So email me if you have any questions or concerns. But again, a lot of the things that I've noticed in paper 3, we are going to rectify with this lecture. And so with today's plan, we're going to prepare for paper 4. So this assignment is, again, designed to introduce you to research in kin. And we're going to, at the end of lecture, talk about what I expect of you for paper 4, when you're choosing your article, kind of what to look for, how to search, and stuff like that. We are also going to learn how to read an academic paper today and just go over very basic statistical analyses, right? Because I think the biggest hurdle that a lot of us find when you first get into research is how they collect data and what that data really looks like. And it can be very confusing and very overwhelming. And so today is going to be about exposure. Not to say that you're going to have all the answers and everything makes sense immediately, but I do want to at least show you some things that you might see in the coming, weeks that you're going to be doing this project. And so the first thing we're going to talk about with the context of paper 4 is picking your topic. And a lot of what I really implore with you all is to pick something that's of interest to you. Or something that, again, in your reflections or your studying, find that maybe you are curious about one topic or another. And just to give you kind of a brief overview of what we've already covered and what we're going to cover this semester, we have sport and exercise psych, so anything from personality, motivation, self-determination, arousal, anxiety, imagery, mental health, and choking. All these things would be really good to research. For exercise phys, fitness in various populations, different tissue and body systems on fitness and nutrition, the physiology of the body overall. We also have biomechanics coming next week, and so this is really getting at structure and function of the body. So this is things like forces, angles, velocity that really influence movement and performance. You can also do some research on motion capture, other things that help us visualize and simulate movement. We also talked about motor behavior, and so this was motor learning via practice or feedback, motor control via body systems and theories, and motor development over a lifetime. So if anything interests you about how we learn skills of movement, that could be of interest in that section. And then finally, we have fitness. So this would be like describing a training technique that has been used or can be used to improve fitness. But I really emphasize that, again, this project is going to not be super enjoyable if you don't pick a topic that you like. And it's going to take some trial and error to really find something that is of interest to you. And that's research, right? Like, that's totally fine. And again, we're going to spend lots of time searching on how to read a paper, what to look for, and if these things that you find are of interest that you actually do want to write about. And so with that, again, not only do we have our context of what we've learned so far, but these are other things that you can use to kind of elicit what is of interest. What kind of questions do you have about this class? What have you always been curious about in terms of kin, in terms of other things that are very exercise, nutrition, fitness based? Or if maybe you don't have any questions, ask your friends or family if they have any questions about what you do or what you're studying. If you have clients, if you have a job that elicits questions from clients and people, what do they not have answers to that you can help research? And so when you consider these things, there's a lot of curiosity surrounding kinesiology in your life. And again, you're brand new starting in this field, so I'm sure you have a lot of questions about things. You don't have all the answers. And so how do you go about addressing these questions? Well, the first thing is that you're going to acknowledge those questions, write them down, and then use research to try to find these answers. And if you can't find these answers, then that's when you start to do your own experiments when you get into your later upper divs, upperclassmen, and even graduate school. But as we're going through this presentation, again, I wish we were in person, but the scheduling of the semester just is not ideal. Do take a moment and write down a few questions or curious points of interest, something that you can use for this purposes of paper 4, and just take a moment and write down a few questions or curious points. And again, I'm just, for the sake of time, going to go ahead and move forward. But when you have your key points or things that you're curious about, maybe a question, think of key phrases to describe that question or point, and usually one term, a certain population, subject area, within 3 to 4 words, right? So if I was, curious, I'm curious about how body image can affect sport performance. And so that would be like how does body image affect sport performance? I would say, okay, body image is an important part of that question. Sport performance is also another. And so those are kind of my 3 words, right? So I have that as my chunk. And so that's what I would use to look at my papers, right? I would use those key phrases, go to Google, which we'll do in a moment, we'll show you. And I would look at these things, and then things would pop up with those interests. But before we even get into that, we have to know the difference between scientific and popular science. So scientific science obviously sounds very redundant, but scientific science comes from reputable researchers versus popular science, which comes from public misconceptions. And so this is why we did paper 3, was to showcase that in the 176 of you in this class, we can find 176 examples in which this popular science sometimes outweighs the reputation and the education and experience that a lot of these researchers have that actually help us support these ideas of health and fitness and exercise and all these things. And so a lot of what you found was popular science through social media. And again, social media is extremely accessible. And so that's why I wanted us to use this platform, this medium, to really showcase how much influence it has and how it's up to the individual to really do their proper research. Because if they don't, and all they see is stuff on social media, whether that be stuff that they were paid off to say, or whether things that they were fortunate enough to have already been endowed to them, whether that be body type or body composition, but it can be very fictitious. And so I hope that a lot of you recognize that in your research, but there's a lot of stuff that we see that's science or health-based that actually isn't necessarily true. And so a lot of you, you're like, okay, well, maybe the next step is to look at blogs, right? Something that's that's also accessible, not nearly as accessible as I'd say social media is, because it's another layer that you have to do your research. But these can either be written by doctors or it can be written by people in the field. And it's their personal blog, personal anecdotes about health and fitness and things that, again, we are pretty concerned about in this class. But unfortunately, this is still popular science. Yes, they might have the experience, they might have the credibility, but the research that's done isn't necessarily reputable. And there's going to be a couple reasons why, and we'll talk about this in a moment. And so when you're doing this paper, paper 4, do not write about someone's personal blog. Even if they're a doctor, even if they're a physical therapist, this is still considered popular science. And so what we're looking for is scientific science. And so this is a group of papers these are the papers that I assigned to you for this week. And so this is really what we're looking for, right? It's published by a journal, and a journal is basically kind of like a magazine that collects different research, different data, different experiments that people do in the field, and basically give it to you in a very compact way. And so if you'll notice that in the Journal of Exercise Physiology Online, it has a date as well as a volume and a number, just like magazines would have. And so it's very similar to that. Usually you don't have physical copies of these journals anymore, although I still do. I get them in the mail just through my subscriptions and professional compliances, continued education, but most of the time they're online. And so when you do this project, I'll say, don't use online sources, don't use online sources. What I mean by that is don't use social media and don't use online blogs. You will find online journal articles such as these through Google, through PubMed and other various search engines. But again, this is really kind of what we're looking for. They follow very similar formats. Usually at the top, it's the journal title, as well as the, volume, the page numbers. Right underneath that is the title of the article. Underneath that are the authors, the researchers of that article. They go into the abstract and then get into the paper, which again, we're going to break down all these different parts of what these journal articles really are. All right, so where do we start? Like I mentioned earlier, when you have those key phrases from your point of curiosity, from your question in kin or nutrition or exercise or sports psych or whatever, right? What I want us to do is to let this be like a little pause moment. And I want us to actually, once we finish this slide, I want you to pause this video and I want you to try out using search engines with your key phrases to just kind of get a feel of what it looks like. And I'm going to go through a couple of different slides to highlight what it was like for me to look at these things, but I think it's a bit more tangible for you to do it. Just so you get the idea of what it's like, what it's expected of you. And if you have any questions about how to, again, search and look up research articles, then that would be the question for me. But again, we're going to start with a library search engine or Google Scholar to track down an article that is of interest to us. So CSULB, because you're a student, and because a lot of these journals have paywalls in the sense that, these researchers do work and they do it usually for free. And so a lot of these journals kind of compensate for that by charging people who want to view their articles behind a $5, $10, even $50 paywall. But because you're students, CACLB has agreements with a lot of these journals so that accessing these websites and accessing these journals are free for you. So very beneficial for you that you're a student. So don't pay for anything, even if it's something that you're really interested in. For the sake of this project, it is not necessary for you to buy a journal article, although you might find that. So again, don't be deterred or scared that you'd have to pay, again, $15 for just reading a research paper. Just back out and find something else. So again, you can go to csulb.edu/university library, and this is where we have one search. So this is, searching everything. And if you hit that drop down arrow, it might have a bunch of different subspecialties. And then what are you looking for? This is where you would put your 3 to 4 keywords to help guide you in the right direction for that article. Some of the search requirements that I do have for this paper, I want you to find something from this century. So it had to have been published between 2000 and 2023, which again, once you start looking at things, you're going to find that there's a lot out there. But usually, again, as we acknowledge, science is ever evolving and sometimes science gets outdated. And so I want us to continue to find things that are relevant to the now, as recent as we can. And so that's why I want us to try to find stuff within the past 23 years. The second thing you're going to do is that you're going to ensure that it's been peer reviewed. Essentially what this means is that when a researcher, does research, does data, they wrote the paper up, they hand it off to someone in the journal, and someone in that field that knows a lot about what they did in that research looks it over. And they make sure that they maintained ethical guidelines. They made sure that they were actually truthful in their data collection, things like that. But the peerness is someone that's in that respective field, that knows what they're talking about, that can help kind of review things to make sure that what was done in that research is legit. Most reputable journals already do this already, but it is important to know and to keep in mind when you go forward in this research, just to make sure that it's peer reviewed. And you can usually find that it's peer reviewed if you go to the journal homepage. It'll say like, this is a peer reviewed journal for blah, blah, blah specialty or whatever. And then obviously the last thing is making sure that it's published by a reputable journal. And just by kind of looking at where you get your article, you'll kind of deduce if it is from a reputable journal. It'll be very legitimate. It'll have links to the homepage for the journal. It has a year, it has a volume, it has page numbers, it has all the things that showcase that it is legit. And so let's look up some papers. And so we're going to do our Google search in a moment. And when we do our Google search, a bunch of stuff is going to pop up. And a lot of it might sound interesting to me. It might sound like it's going to answer my research questions. But I need to look at two things first before I decide to really put a lot of effort into reading these research articles. The first one is the title. That's the first look, because it should give you a good idea about what the article is about. It should be attention grabbing. It should be informative, not too long. And so as soon as I read the title, I'm like, okay, like that might be interesting to me. The second look that I do is the abstract. So the abstract is kind of the introductory paragraph. And what this introductory paragraph is that it gives you a snapshot of the literature surrounding this research, kind of what's been done before, the education surrounding what they were looking at. The second thing that it says is the methodology behind the study and the experiment. So really what they did in this research. The third thing that it does is that it showcases very, very brief results, the data of what they found in that study or that experiment. And then lastly, a brief sentence or two about the discussion, the implications, why this is important. And so let's say I go to Google Scholar. Like I said, I'm very interested in body image and sport performance. And so I even went a couple steps beyond and I put sports psychology, body image, sport performance, right? And so I go into Google Scholar. And so again, it's Google Scholar, not just Google, because Google can put back social media, it can put back blogs, but usually Google Scholar does a good job in making sure that the articles that are coming about are legit. They're research articles. And so I'm looking through these. I'm like, okay, I'm really interested in body image and sport performance. And so I look at this first one, current issues in North American sports psychology, identification and prevention of weight pressures and body image concerns among athletes. I'm like, okay, it's important to acknowledge these things, but not really what I'm looking for. So I go to the next one. Using narrative therapy in sports psych practice, application to psychoeducational body image program. Like maybe, but not really what I'm looking at. It's not performance based. And so then I go to the last one that says examining body image, sport confidence, flow state, and subjective performance among student athletes and non-athletes. That sounds awesome. That sounds exactly what I'm looking for. How does body image impact sport performance? And you'll notice that it's usually not just so simple. You'll find that there's other things kind of involved in this research. So this one also has the discussion of non-athletes, talking about flow state, sport confidence. So all these different things impact what I'm really looking for. And so I say, okay, I'm going to click on that. The title seems interesting for what I want to research. And so this is what we're going to find. So again, we're going to basically go through this paper and really hit all these different points on a research paper, what to look for. And this is the pretty standard format for pretty much all academic papers. And so again, the first thing we're going to do is look at the titles and the authors with their credentials. That's our first step. What's this paper about? Who wrote it and did the research? It's important to know that the folks who did the experiments actually have the education and credentials to do so. Typically they are, but it's just something to keep in mind, making sure that where you have this reputable research, making sure that it's legitimate from the people who wrote it. Again, the second step is the abstract. It's the snapshot of the paper, gives you a basic intro, methods, results, and discussion sections. And so let's go ahead and look at this paper, right? First step is to look at the title, which is, again, a very quick overview of what that paper is about. So examining positive body image, sport confidence, flow state, and subjective performance among student athletes and non-athletes. Sounds awesome. And so for the next step, it's finding out who the authors are. And so are the researchers and authors qualified to do this type of work? And so what you'll find is that right under the title of a research article, they have the list of the authors that were involved in the writing and the experiments of the data collection of this experiment or this research. And so what you'll see most of the time is that you'll have a name, and you'll have either a subscript or another letter that just indicates kind of where they are. And so if you look over here, you'll see here are all of the names, and there's an A, B, and A. And so usually they'll find that these, letters indicate where they're from, what type of university they work for, what type of private practice they work for. And so for all the folks that have an A next to their name are part of the St. Louis University Department of Psychology, right? And so then they have the address of the university, and that just basically showcases that either they're a professor or they're a faculty member or they're a student. And in addition to that, you'll often find that at the bottom, there's a corresponding author note in which if you had any questions about this research, you're able to reach out to the corresponding author. Usually it's the first author, and it has their email right here. And so in addition to seeing where they're from, you also see their email at slu.edu. So that's a legitimate email from an institution. And so that's how you know, okay, they know what they're talking about. And so for our B person is from Novant Health Orthopedic Service Line. So this isn't necessarily from a university, but also from the private sector. So you might have a little bit of both. But generally, we find that folks who have published work, they're legit, they come from reputable places, and so they are qualified to do this research. But again, this is where we find these things, and this is kind of where we make that distinction. And then finally, we have our abstract. So the abstract is usually right underneath the authors. It could be next to the article information, but this is where we find the abstract. It's usually the first chunk of text that we find in this type of research article. And so again, snapshot of the paper where you have a basic intro, methods, results, and discussion section. So this is from the Souliard paper. So this Souliard is kind of what I'll just refer to it as. I understand there's a bunch of different authors, but we'll get to that towards the end. So the snapshot of the paper is the abstract, and this is what the abstract is. That's a lot of text. It's a lot of stuff. And so what I recommend at least doing in the beginning, once you find an article that you like, is to break it up by its respective parts. And again, an abstract will have all four of these elements. And if they don't, then you should probably not use that article for your paper. And so again, the first thing that it does is that it provides a basic introduction. And so the intro I highlighted in green. And so that's where we see the intro, the purpose of this experiment, what has been done before, why they're interested in this type of research. And so this is where it's highlighted in the beginning. The primary purpose of the study was to examine differences in positive body image, specifically body appreciation and functionality appreciation between student athletes and non-athletes. That's pretty straightforward. That's exactly why they're doing this. A secondary purpose was to examine the relationships between positive body image and other sport-related variables. Sounds great. That gives me a good idea of what they're looking for and the purposes for why they did this research. The second thing that's highlighted in blue are the methods. So really what their research was. Who were they talking about? Who were they interviewing? Who got the survey? What did they actually do? Who were they? And so the methods, as per the abstract, 79 National Collegiate Athletic Association NCAA D1 student athletes, in which it gives their mean age. So they're about, 19, and 175 non-athletes, in which they're also about 19, completed measures of body appreciation and functionality appreciation. Athletes further completed measures of sport confidence, flow state, and subjective sport performance. And so measures is a good kind of indicator that this is going to be survey research. Additionally, you'll find that, again, this is a good nod to really who they're targeting. So student athletes and non-student athletes, how old they were, what they did, and moving forward from there. And so then the next sentence are results. So again, very basic stuff. Student athletes reported higher levels of both facets of positive body image. Significant relationships were also found between positive body image and sport-related variables. That's basic what they found, right? They found what they were looking for. And then finally, we have the discussion. So the discussion is, again, why is this important? What can we take away from this experiment? And so the present results contribute novel findings to the positive body image literature and potential implications for coaches to encourage a culture that focuses less on body appearance and more on cultivating positive body image. And so in addition to saying, why is this important, they also can talk about why or how this can be used in the future. What future implications can be used to help people in the future learn from what we found for a better sport culture, for a better community going forward. So again, abstract gives you all 4 of these elements as a snapshot to really give you a good idea of what you're going to be reading about in much more detail. And so now let's continue to look up some papers by asking ourselves, while we're reading abstracts, is this something that I find interesting? Do I understand everything that the abstract says? If you don't, then that might not be necessarily a worthwhile article, because you're not really getting a lot of the content that they're trying to relay to you. Do I need to do some other research for that to make sense? And so again, it's not to say that when you start this project that it's going to be the first article you find is the one that you're going to do this paper on. You might have to do a lot of trial and error, and that's kind of the whole point of this project. And so, once you find something, you're like, I don't really understand it. I don't really know if this is something that I want to do for this project. Is this worth my time? And if you say no, then that's fine. Move on to another article that makes more sense or that is of more interest to you. And so to kind of give you a brief overview of what to expect after the abstract is just kind of the layout of what a paper looks like and kind of the flow structure of what to expect in terms of applicable knowledge. And so the first thing that we have is the introduction. And so again, this is introducing relevant literature, explaining why your study is a novel, as well as listing your hypotheses. And so again, it starts pretty broad in the sense that here is all of the available information about this topic. But what I want to find is much more niche. It's a lot more specific as opposed to this great body of knowledge that I just acknowledged. And so once you kind of have a funnel, you have a really specific idea or question, this is where you identify the knowledge gap. And it's like, well, in all these things that we found, there's still some answers that are left to be is found. And so this is where we have our hypotheses. Based on what we know, we anticipate XYZ will happen because no one has ever done this experiment before. And so the next step are materials and methods. And so this is introducing the study system. What are we actually going to do for this research and this experiment? The second thing is explaining methods such that your reader could replicate this study. So it's making sure that we are transparent in our research and a lot of, again, peer review processes is not just making sure you're an expert in the field, but if you wanted to replicate that experiment, you should find the same results. And there's a statistical kind of component to that expectation. But it's important that you list things out in enough detail that a stranger or someone that is in the field could easily replicate it and then, again, hopefully find the same results. And so once they do the experiment, then you have the results. And so this is when you objectively state the findings, you focus on the results, and use statistics for support. And so this is the action, right? So you have our knowledge gap. This is the experiment. This is what we found. And now we're back into the discussion. So again, you're interpreting your results. You tie your results back to the literature you talked about in the introduction by acknowledging that what you found either fills the knowledge gap or you found that maybe it doesn't, but it could lead to other questions in the future. And so this is finally where you get conclusions and implications. It becomes much more broad again. So again, it starts broad. Here's the swath of knowledge that's already available to us. Here's something that we haven't found the answer to yet. Hopefully we have some answers. How do we apply that to the greater world? How can we use what we found to contribute to the greater body of knowledge in the broader sense? And so that's really kind of what you'll expect to find is this hourglass looking figure in terms of information and how it applies to things outside of the experiment. And so the next thing we're going to look at is the introduction. And so this is where we have the foundation of this information as well as our hypotheses. So what did the literature review talk about, right? What is this already existing body of knowledge? What questions did the researchers have? So what is the knowledge gap? What do they want to find? And what did they expect to happen? And what were their hypotheses? And so the introduction is the very first thing after the abstract. And then usually it's APA format is very helpful in this way, in which there's actually usually a title that says introduction. So you know exactly what you're looking at. And again, introduction is where you introduce relevant literature, explain why your study is novel as in new, and your hypotheses. And so the two purposes of the intro is, again, discuss the supporting literature and stating your purpose as well as your hypotheses. So again, number one, you're presenting your relevant research that's already been conducted. This is where, again, we do research, we cite folks, we have other people contribute to our arguments, to our knowledge basis, and so that is why this is important. We also have to acknowledge the theories behind why you do what you do. And a lot of theories are very old. They're from the 60s, 70s, depending on what specialty you're looking at, as well as just other literature that supports your rationale for your purpose and hypotheses. So what do we know and how does that get to where I have questions? And so you'll find that, again, it starts pretty vague. It becomes more and more narrow, and we'll see that in a moment. The second purpose are the hypotheses on what the researchers expect to happen based on the variables of the study. And so we are going to be going over two different types of hypotheses and two different types of variables from those hypotheses. But the first thing we're going to do is, again, this first purpose of starting with a very broad sense of literature, a broad sense of research, and then narrow it down to specific topics, hopefully getting to a place of a knowledge gap. And so for the Souliard paper, the following are the headings of the different structures of the introduction, which again, APA format tries to be as clear as possible. This is the intro. This is what I'm talking about in this section, this section, this section, this section, going all the way more narrow until we have our current study. And so again, the intro is the overarching kind of theme of this part of the paper. Then it gets into positive body image. There's a lot of research on positive body image. Then it funnels down to say, okay, well, not just positive body image, but also athletics, right? How does that narrow down into our sports space? And then the next step is positive body image, flow state, sport confidence, and sport performance. So taking positive body image in athletics and funneling it down even more. And then finally, the current study, where in what we find in this very niche space, is there still knowledge acquisition to be had? Then we have the different types of hypotheses. So this is getting into purpose number 2. So a hypotheses or singular hypothesis are what researchers expect to happen in their research. And so they try to see if there's an effect between two different variables, independent versus dependent, which we'll get into in a moment. And so like I mentioned earlier, there's two different types of hypotheses. A research hypothesis is what most of you will find written in your papers. Sometimes they're called alternative hypotheses. They're usually denoted with an H subscript 1. usually worded as the current study predicts, or we anticipate the following to occur. It was hypothesized, blah, 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 right? And so this is what we will find written out. The reason why we have two different hypotheses is because a lot of the statistical analysis really tries to target this null. And without going into too much detail, again, you'll get statistics classes in your time here. But just do know kind of the rationale behind the reasons why we do statistics and really what it's targeting. And so the research hypothesis is what you will find written, although the null hypothesis is really what most statistics are attempting to support. And so again, it's not proving anything, it's supporting. And so essentially what you're doing in research and statistics is that you're trying to reject the null because the null is the opposite of the research hypotheses. And the null is usually denoted with an H subscript 0. And so essentially what happens is if your data provides enough evidence against the claim, there's no effect in the population, then we can reject the null, which helps support the alternative hypothesis statistically. And essentially what this comes down to is in philosophy of research and philosophy of science, it is much easier to disprove something than to prove something, right? And again, proving is impossible because to prove something, it's to say that there's no more knowledge acquisition that can ever happen. And so by disproving or unsupporting the opposite, then you as an effect are supporting the purpose, the actual predictions. And so that is why we have these two things. But just know for this class, the research hypothesis is usually denoted with an H1. This is what researchers will disclose. However, the null hypothesis, usually denoted with an H0, is what statistics aims to dissupport. And so to give you some examples of really what this is visually and in terms of research, my research question is, do smokers weigh the same as non-smokers? So we have two groups, smokers and non-smokers. Do they weigh the same? Or do we find that on average, smokers weigh a different weight than non-smokers? And so the null hypothesis would be, okay, let's start with the alternative, right? Let's say I think that as a researcher in smoking, that smokers will weigh differently than non-smokers. And so the mean weight of smokers is different, not the same, not equal to the mean weight of non-smokers, right? The research might show this, but statistically we have to say, the null is that the average weight does not differ. And so the mean weight of smokers is the mean weight of non-smokers, or about, right? And statistics will show us if this is true. If this is true, then we have to reject the alternative hypothesis. That is not necessarily what we found. However, if this is not true, then we can accept the alternative hypothesis in which that difference actually occurs. And this will make hopefully a bit more sense when we get to our statistical results, but just know difference between research hypotheses, sometimes called the alternative, H1, usually what's written in papers. Null hypotheses, denoted with H0, is what statistics are attempting to support. And now we have variables. So there are two different types of variables in research. I mean, there's a ton of different types, but generally, and again, more umbrella terms, we have things that are, presented in the form of a hypothesis as an independent variable and a dependent variable. And so an independent variable, or IV, is the cause. And so this is what is being manipulated or controlled if the measure can't be manipulated. So these are things like age or gender or height. Usually the independent variable is the difference maker. And so when we look at this example again, the independent variable would be the cause. So this would be smoking behavior. And so smoking behavior would be the independent because it causes other things to happen. It is what is being manipulated or controlled for because you have either smokers or non-smokers, independent variables. You cannot really have an effect on this. As a contrast, the dependent variable, the DV, is considered the outcome. And so this is the effect of the independent variable. You never directly manipulate the dependent variable in the sense that weight. If you make someone gain weight, does that make them a smoker? No. And so there's usually a linear cause, but it does get a bit more complicated, and we'll get to that in a moment. So again, in this example, the independent variable would be smoking behavior, whether you have smokers or non-smokers, and the dependent variable would be the outcome, which for this instance is weight. So again, independent variable, smoking behavior, dependent variable is weight. And again, in non-experimental research, the independent variable and the dependent variable are not as clear cut. That's why for the purpose of paper 4, do try to find experimental research. It will make a lot of this a lot more digestible, easy to understand. And so to kind of highlight that in non-experimental research, the same variable can be the IV or the DV depending on the question. One example of this, how does stress influence balance beam performance? In this example, stress is the independent variable. The dependent variable is beam performance, so like gymnastics. However, another question could ask, how does progressive muscle relaxation influence stress? So now our independent variable is progressive muscle relaxation, and then the consequence, the DV, is stress. So you can see how stress can be an independent or dependent variable depending on what you're asking for. And so again, try to find experimental research. This stuff will make a lot more sense if you do try to find something that's experimental. And so as some kind of practice opportunities, let's take a few moments to figure out which of the variables that are listed in these research questions are the independent and dependent variables. So the first one is, do smokers weigh the same as non-smokers, right? We just talked about this. So for this question, do smokers weigh the same as non-smokers? Independent variable, smoking behavior. Dependent variable is weight. For the second question, are tall basketball players more confident than short basketball players? So again, independent variable is the cause, dependent variable is the outcome. For this example, the independent variable is height, tall versus short. The outcome is confidence, right? And again, I like to kind of use this linear example of, if someone is more confident, does that make them taller or shorter? That doesn't necessarily work, right? So you have a linear effect of IV versus DV in this question specifically. The last one is does body satisfaction differ between male, female, and non-binary swimmers? So when you consider the independent variable, that is gender, right? So it's the cause. So gender, male, female, non-binary, these are 3 groups. The outcome is body satisfaction. So again, I wish that we were able to do this in class, but do kind of have, again, exposure to this type of work. And if you have any questions, let me know. And so now we're moving into methods. So this is what they did, right? We have all the foundation. We have what we think is going to happen. So now let's think about what the researchers actually did. What kind of study was performed? Was it experimental, correlational, descriptive, etc.? Was it qualitative, focused on words, or quantitative, focused on numbers? Who were the participants? What did they have to do? What type of data or measurement did the researchers collect? And so let's talk about the 4 main parts of a methods system. So again, the methods introduce the study system in such detail that the reader could replicate the study. That's the point. The first thing is the participants. Who are the people doing the study? Second part are the measures. And so this is, what are the methods used to collect participant data? Procedures are, what did the participants do? Data analysis, what data analysis are they going to do in before they get to the research or the results section? Additionally, what you'll find, again, this is more for exposure as opposed to noting things, but they're going to often add a line in which they got Institutional Review Board approval, IRB approval from their institution or company. And what the IRB is this external objective committee that reviews the study proposal for ethical maintenance and sound research skills. Essentially what this is the first step in order to do research, right? You have this idea, you have the intro, you want to do something, but you have to get it approved by someone else. You can't just go willy-nilly and do research like you would any other day. In order for research to be reputable and ethical, it has to be approved by the IRB. And again, all universities have an IRB, all research institutions, private or otherwise, have an IRB. But just do know that that is something that you might see. Not to be scared. Actually, it's a positive thing because it shows that they did their due diligence in making sure their research is legit. And so the first thing we're going to look at are participants. So again, going back to the Souliard paper, in the methods section, again, APA is very good about putting titles on things. The methods section basically says, well, the first thing we're going to talk about are the participants, right? These are the people who did the study. Major things to look out for: a number of participants, the average age and age range of the participants, highest demographic percentages, and any other identifying groupings that are pertinent to the study, right? And so for this case specifically, we're looking at athletes versus non-athletes. But if you're looking at, let's say, kids, you'll say, well, these kids are in elementary school versus kids that are in high school. And that will be disclosed in the participants section. And so again, number of participants is usually disclosed very early. And so for the Souliard paper, it's 254 undergraduate students. You'll find that how they sometimes disclose that is with the letter N, which is denoting of subjects, equals 254. And so if you see that, then that's how you know that this is the amount of people that were used in the study total. It's also important to know how large this population was for statistical support. G-Power is a program that basically says, this is the experiment that I want to do, and it'll spit out a number knowing your survey, knowing your interview questions, knowing what you want to do. And essentially what this does is say that in order for something to be scientifically and statistically sound, you have to have a minimum of these number of people. And so most researchers make sure that they satiate the G-Power requirement. But again, for the purposes of this class, just look at the number of participants, and still it's important to know these things and how it applies statistically. The second thing you'll find is the average age and age range. And the reason why they include this is because, you kind of want to know the demographics of the folks that you're doing this research on. But it's important to know that different generations have different responses to certain things. And so we'll find generally that most research is done on college students. And there's a couple reasons for that. The first one is that for research on kids, it gets a bit complicated because you have to have parental consent. And so that's just another layer, another hoop to jump through to make sure that, again, you're being ethical with children and their parents know what's going on. And the second reason is because a lot of research is done on college campuses. And so either by professors, faculty, students, what have you, because they're on these college spaces, you have a readily available population to you already. And so, as I'm sure you've noticed in this class, there are many different groups that come in because you're just readily available for the picking. You come and you have your own autonomy legally, you're adults, and so that takes out the parental aspect, and you're in one concentrated place. So you'll find that generally, unless they have explicit purpose of researching children or other older populations, you'll find that most people in most of these experiments have college age ranges. But you'll find that with this denotion of M, which is the average, so M is mean, the average age, as well as this age range. And so usually that's denoted with a standard deviation, and we'll get to standard deviations when we get into our research or our results section. But essentially what it is that this is the average mean, and this is where most people fall above or below that average mean. And so either, most people really kind of identify with this mean, but there is still a bit of a range. But usually if you have plus or minus 1.64 from 19.5, it's still around 19. The standard deviation age range is not very large. And so it's important to know the average as well as the age range of a certain population for this accurate representation. And again, it's important to know too, because a lot of statistical analyses basically say that, what we found can be applied to the general population. You're only surveying college kids, so it's really inaccurate to say that, yes, statistically it might be applicable to the general population, but when you consider really who you're surveying, you have to be a bit more tactful about that representation. The third thing that we find are the demographic descriptions of the participants. And so depending on the research, depending on the researcher, they'll disclose either a lot or a little about the researcher participants. And so this can be anything from talking about their age, gender identity, race, ethnicity, sexual orientation, athlete status, sport, other things that you might find, weight, height, year in school, BMI, disease state, condition. But these are things that are maybe not necessarily pertinent to the research itself, but it's important to, again, have a better understanding of who these people are and how applicable the research or the findings are to the general population. Because if you find that, mostly women took this study, to say that it's applicable to the general population wouldn't necessarily be true. And so that can also be said for race, ethnicity, sexual orientation. So again, just things to note. And you'll find, again, whether or not they disclose a lot to you or not is usually found in the form of a table. And so this table 1 is the demographic characteristics of student athletes and non-student athletes. So you'll see the athletes in this column versus non-athletes in this column by gender, by race, ethnicity, and sexual orientation. And then finally, we have groupings that are pertinent to the study. So for the Souliard paper, it's athletes versus non-athletes, right? We want to see these different positive body image experiences between athletes and non-athletes. And so it's important to note the number of groups, if there are any. Generally, you'll find that for people that do experiments, there are going to be groupings, whether that be by athletic status or by gender or by age. Groupings are necessary for comparative experiments. And so, like I said, typically this is what researchers are comparing, so the independent variables. So the next thing we're going to talk about are the methods and procedures. So again, there's two general types of data that can be collected in research. The first are quantitative research data, which are numbers. So this examines research through statistics, larger sample sizes, very numbers focused. But the caveat to that is very sterile and unnatural in the sense that it's very much numbers based as opposed to more humanitarian based. And an example of this type of research would be like on a scale from 1, not confident at all, to 10, very confident. How confident do you feel to be able to shoot a 3-pointer right now? And so that can be something that is very accessible. And you say 2, 3, 10, right? And so then that confidence is equated to a number. That cerebral kind of theory, that feeling is now deduced just to a single number, which again, it's very easy to compare. It's really easy to do statistical analyses on numbers as opposed to words. And so this is where we get qualitative data. So qualitative research data is very in-depth. You have a much smaller sample size. You have much fewer participants that you're asking about. It's very people-focused, but as a caveat, it's timely and very costly. And so as an example of this, after an intervention, what suggestions do you have to improve our outreach to student athletes? And so it's usually transcribed, it's usually in the form of words, and just kind of highlighting the difference between these two types of research. In order to get this type of research, you can have many different research methods to get different types of data. So observations, surveys and scales, interviews, and experiments are the ones that I want to focus on today. There are others, but for the purposes of this class, these are things that you might find in your research for paper 4. And so the first one is observation. And this is where you go into a natural setting and you watch for certain behaviors, certain forms, or certain dialogues. And observations can be quantitative or qualitative. And I used to do this, I was an undergrad at one point too, and I was part of this class. And with this class, it was an animal behavior class. And the professor of this class was the director of the Los Angeles Zoo. And so she was, the big hotshot, and I felt very honored to have her as a professor. But essentially what she did is for a project, she said, okay, you're going to go and watch this animal, and you're going to check if this animal does a certain behavior. And so I was assigned to a toucan. And so I would go and watch this toucan, and I'd have my sheet, and, toucan behaviors are jumping, flying, pecking, various things. And so I would look and I'd watch, observe, and if the toucan did that thing, then I would check mark by that thing. If he did another thing, then I'd check mark that thing. And so this is numerical because at the end of the hour or whatever that I was observing, I'd tally up those behaviors and I'd say, this is what the parrot or the toucan did in this hour. It can also be qualitative, because if I were to go into that space and she said, write down everything the toucan did for an hour, and I would write that down with words, right? And so I would say, oh, like the bird pecked for 20 seconds, then the bird flew for 5 seconds, and then, all these different things. And so it can be either quantitative or qualitative. Surveys and scales is where you take a test that assesses your opinions, feelings, or perspective on a Likert type scale. So if you see something in your, exposure to paper 4, where in the methods section it says that we used a Likert scale. This basically just says that, Likert scale numbers equate to a certain value or characteristic. And so when you had the example of the quantitative research, this is a Likert scale because 1 means not confident, 10 means very confident. And then the numbers in between are existing on that spectrum between not confident at all to very confident. That's what essentially that means. And so Likert was based off of a researcher that did this type of kind of stuff. But generally we find that surveys and scales are pretty much exclusively quantitative. Because they focus on the numerical association of values for statistical purposes. The numbers are the most important thing for most surveys and scales. Interviews are structured or semi-structured or unstructured. So structured is you have certain questions, you can only ask these questions, and that's it. Semi-structured is where you kind of, you ask those questions, but maybe you want to delve a bit more into one of the answers. And so it's kind of structured, kind of not. And then unstructured is just kind of a free-for-all, right? You get into this space and you start to have a conversation with someone. There's not really procedures. And so most research does not do unstructured interviews. Although we do have to acknowledge that they can occur. But generally we find that these interviews are qualitative. They're very much more focused on the language of what was responded to, how they responded to these questions, what they really said, and they're usually transcribed and written about that way. And then finally we have experiments. So experiments can be qualitative or quantitative. And typically we find that the people who come in should represent a random distribution of the general population. And of these exposures to the experiment, either they're manipulated or they're not. And usually this is considered the control group because they're used as a comparison to the group that got the manipulation. And so it can be either quantitative or qualitative. And for experiments, we find that for folks that are in the control group, they're usually done so in a double-blind study. And so that's the sense of neither the researchers or the participants know if they're getting the manipulation or not. And so I talked about this with our pharma discussion a couple weeks ago, that for most pharmaceutical research follows experimental double-blind research. And so the sense that, neither the researchers nor the participants know if they're taking the real drug or the placebo drug. And the placebo drug is very similar to the actual drug, same color, same format, same dimensions, but it doesn't have the active ingredient that they're really trying to assess. And so the reason why it's double-blind, participant and researcher, is because we have undue biases, and those biases can come about in different ways. In a research particularly, it can be very impactful because of the undue influences that it can have on the treatment of said participants or their perceptions of success. And so that's where we start to have a lot of experimentation between experimental groups and non-experimental groups, the control groups. Experimental groups also might not necessarily have a manipulation in the most explicit sense. That experiment might just be between gender, in which one group is male, one group is female, and we try to see the differences there. And so, again, either of these things can be quantitative or qualitative. But to go back to the Souliard paper, one of the things that we find is that in this subsect for methods, it also talks about procedures. And so it has scales. So whenever it says scale, that's how it should be known, like, hey, this is probably a survey, right? There's probably a lot of new numbers, and there's probably going to be a lot of statistical analyses, right? And so when you do your online readings, if you haven't done so already, do take note of the method section. Really, what did they do? Was it an observation? Was it a survey or scale, or an inventory, which is another name for a scale? Was it an interview, or was it experimental? And so with that, what type of research method is being used. These are very much survey-based. And what type of data did they collect? Generally, surveys are very quantitative, they're numbers-based. And so what are the other research tools out there? What are the methods that people are doing for this research? And I mean, it can be so much. And that's probably the greatest thing about Kin, is that it is so multidisciplinary. And so you can have blood samples, motion analyses, force plates, body fat assessments, electromyography, video interviews, surveys, VO2 max tests, dynamometers, tissue assessments, pressure scans, exercise adherence, brainwave assessments. So all these different things are available. These are the tools that a lot of people use in experiments for Kin research. And so now we're going to finish up this methods section by talking about what the proposed analyses is for the data that they're looking for. And so typically we see three general means of data analyses. The first one is correlational. And this is where we attempt to see a relationship between two different variables. So again, whether that's experimental group versus control group, men versus women, coach versus athlete. And it's important to know that correlation does not equal causation. And I like this kind of example to highlight this, that we find in research that more robberies happen in the summer. So people that maybe don't know this rule of correlation does not equal causation, well, summer means that robbers come because that's what summer means. That's not necessarily true. Just because it's summertime doesn't mean that robbers are just going to say, okay, I'm going to go rob a house now. There's a lot of other things that might be influencing that. It could be weather. It's warmer outside, so people are outdoors. They're leaving their windows open. They're leaving their doors open. Another thing could be summer break. They're on vacation. They're not home to protect their house, their belongings, all these things. And so, again, we might be very enticed by these correlational studies, these correlational analyses, but it's important to know that correlation does not equal causation. Just because we find this relationship between two variables doesn't mean that that is how that thing occurs. And so it's typically denoted in the results section with a table of asterisks, usually representing significant correlations between two or more variables. And so we'll get to that in our results section. The second means of data analyses that we find are group differences. And so this is attempting to see if there are differences between the dependent variables between study groups. And so we find that, again, when we talked about our smokers' weight versus non-smokers' weight, group differences, the groups are smokers versus non-smokers, and trying to see if the weights are different. So with that, we typically do statistical analyses with this, usually mentioned with a t-test, ANOVA, ANCOVA, MANOVA, MANCOVA, linear regressions. And again, we'll talk about all these things in the results section. And then finally, for the purposes of this class, I wouldn't worry about descriptive studies, so much so that I actually cross it off. But for the purposes of knowledge, descriptive research is starting out with literally no or little preconception to how a study will go. So there's a very limited introduction section, and the research really hasn't been done. There isn't a lot of background. And so a lot of descriptive experiments and research really try to create their own theories from their findings. Essentially what this is again, we talked about descriptive research with our philosophy lecture, is just seeing what happens and doing this research, see what happens, and then based on those results, create your own theories. Generally, we don't encourage people to do this type of research. It usually takes a lot of time, a lot of experience, a lot of expertise in a said field to be able to do descriptive research. And so again, for this class, really try to find correlational or group difference research papers. And when we go into our results section right now, we're going to look at t-tests, ANOVA, and correlations, just so you can kind of get an idea and exposure to what you might find in your paper 4. Okay, so now we're going to shift into our results section of academic paper format. And this is what they found, right? So this is the data, this is the outcome of the experiment. And so what did they find? What were the outcomes of the study? Were the data significant? What kind of statistical analyses did they use? Did they include images, graphs, or charts to help explain their findings? And so in my opinion, this is probably the most overwhelming part of an academic paper, is to see all these numbers, to see all these symbols, charts, graphs, all these things that are very unfamiliar. And so I'm going to go through this as simplistically as I can while still providing you with enough tools to hopefully deduce purpose and making sense of these things, because again, it's relatively unfamiliar. And again, the reason why I do this class is to make sure that when you do this paper, you're not as unprepared as if we didn't do this lecture. And so there are a couple of purposes to statistics. So the first one is to quantitatively answer research questions and test the hypotheses, right? And so this is very much more numbers based. The second thing is that we're attempting to eliminate bias through numbers. And part of the reasons why is because, numbers are relatively objective, and what you find in numbers is very, hopefully doesn't elicit a lot of implicit bias from the researcher or from culture or from language. And so it is still important to acknowledge that statistics can still be subject to bias, but generally we find that statistics through numbers are relatively objective. And with that, they might not be the result you want, but if it's statistically sound, then that must be the conclusion of this type of research. And then finally, like I've mentioned before, statistical analyses allow results from a smaller sample of subjects to be generalized to a larger population. And generally, we want to find that with this group, again, that satiates G power, basically saying that with all these things that you're looking for, you have to have the minimum amount of people to really have an accurate representation of how the world would respond to this question or to this experiment. And so we're going to go through some very basic statistics of what you might find before we really get into the nitty-gritty of it all. So the population, so when you consider a population, this is all members of a specified group. So the symbol is usually denoted with a capital N. Because populations could be thousands, millions, billions of people, it's nearly impossible to have experiments that get every single person from a specific population represented in that data. So with that, we have samples. So samples are usually denoted with a lowercase n, which if you remember from our population or our participants is where we have again, n is represented by the total number of people that did the experiment. And so this is a subset of a population. You use samples to find statistics, and this is really where we work, right? We cannot feasibly have every single person in a country, in a school, in the world take this survey, get interviewed. And so we just have to say, okay, well, if I get a group that is still representative of this population, I can still say with confidence that what I found could be applicable and is statistically supported in this applicability to a greater population. And so there's lots of different ways in which we can look at data. Frequencies, which is really how common something occurs, are usually represented in the form of a histogram, which we'll get into in a moment. We also have central tendency, which is really kind of the focus of a lot of the statistical research, is the mean. Although sometimes we have median and mode, but mean is king in research numerically. And dispersion. And so this is where we have range, variance, and standard deviation. And so, like I said, mean and standard deviation is really the king of this quantitative research. And nearly all statistical analyses foundation comes from assessing mean group differences in research. And I, in my statistics class, actually had to figure all this stuff out. I don't know if that will be your experience, but for the purposes of this class, all of our calculations, which we will have calculations in our quiz and our final, are very basic math. It'll be done without the use of a calculator, but do know that might be the future for you in your statistics classes or research classes. So where we find the mean is usually denoted with a capital M and is the average score. And so what this is, the summation of all data values is represented here, divided by the number of items in a sample, represented by a lowercase n. So you sum all of the results divided by the amount of people that took that survey. And so as a maybe experiment for us, as a measure assessing confidence in sport from 1 not confident at all to 10 very confident, 5 athletes had the following scores: 2, 4, 5, 3, and 5. And I want us to find the mean. So again, you'd add 2 and 4, 6, to 5, 11, to 3, 14, to 5, 19. So I can't do that math in my head. When I do give you these results, you'll be able to do this division really easily. But 19 which is again the summation of all the data values, divided by 5 athletes, which is lowercase n, we come to have an average of 3.8. Which again, considering the scale of 1 not confident at all to 10 very confident, 3.8 is kind of middling. It's kind of in the middle, so they're not too confident in this respective measure, in this respective behavior, what have you. Additionally, you might find subscripts denoting specific mean values. And so if you have something like M age, this is meaning the mean age of a specific population. You also might see M confidence. You also might see M, whatever numerical value that you're looking at. Standard deviation is denoted with SD and is related to sample size. It's not as clear cut just because standard deviation is entirely dependent on the mean as well as the distribution of the associated values. And so if you ever were to do standard deviation, this is essentially what the formula is. You have the sample standard deviation, and so this can come from many different sources. And again, without getting too complicated, it's the sum of each value minus the sample mean of all the values squared divided by the number of values minus 1 and rooted. And so again, very complicated. For the purposes of this class, we are not doing this, but it's important to know where these things come from. But essentially what this is that the standard deviation is how closely everyone else outside of the mean deviates from said mean. And so a low standard deviation indicates that values tend to be close to the mean of a set, while a high standard deviation indicates that the values are more spread over a wide range, right? It's not as peaked, it's not as concentrated in the middle, in the mean, it's more spread. And with that, the range sets the highest and lowest values of any variable. So for age, you'll often find the ages range from 18 to 38. So all of the participants' ages must be between 18 and 38, even though the mean for this population was about 19. So it's again acknowledging that there are some outliers, but generally we find that people usually gear towards the younger side of this range. For scales, you often see on a measure assessing confidence in sport from 1 non-confident at all to 10 very confident. So all the confidence scores must be between 1 and 10. So it gives you a range of what you should be looking at. And so the reason, that we even talk about standard deviation, range, and I'm a very visual learner, and so I wanted to present this to you all. That made sense when I was learning about statistical analyses of why we find these things and really what it looks like in terms of distribution. And so the normal distribution curve is really getting at this idea of what the mean is in a respective scale, how far away are the other results from that mean, and what that really means. And so this is a visual representation of mean standard deviation among a randomly assigned population. And when I say randomly assigned, it's not purposefully putting all women in the experimental group and all men in the non-experimental group. It's randomly assigned because it should be representative of a random group in the sense that there isn't any potential bias towards gender, race, ethnicity, age, all these things. So it's randomly distributed and a representative of a population. And so it asserts that in a normal population, in the sense that normal is, there's a mean and all associated values kind of distribute themselves in this very standardly. And it's actually kind of astounding how often behaviors fall in this type of way. But anyway, we find that in a normal population of random people, the data points tend to distribute themselves in this fashion, in which there is, again, a mean. Most people would answer very similarly to this mean. 68% would be very similar, very close to that mean. 95% would exist just 2 standard deviations away from the mean, in which nearly everyone else would exist between 3 standard deviations. And again, I'm going over this relatively quickly. You should spend at least a week to a couple weeks really kind of digging into what normal distribution curves look like in statistics. And again, maybe this is review, maybe this is brand new. So again, this is why I want to encourage you all to ask a lot of questions for this stuff. I understand that it's it can be very confusing and very overwhelming. And so the average score, which is a mean, is usually denoted with a lowercase mu. And so this is where we get a lot of our Greek symbols, but this is mu here. Sometimes research has mu, but usually it's m. And we find that the standard deviation from the mean, SD, is denoted with lowercase sigma. And so you see sigma here. Essentially, this empirical rule states that 68% of the distribution lies between one standard deviation of the mean. And so again, that 68% of all values fall close to this mean. And then 95% fall within two closenesses of this mean. And again, positive and negative doesn't necessarily matter because for the purposes of this, it's really not about positives, negatives. It's just about how far away something is from the middle. And so to kind of give you another visual of just truly how astounding this representation visualizes itself is this, and I forget the name of it. Let me find the name of this really quick. This is called a Galton board, Galton, Galton board. And so this Galton board is, again, a visual representation of the theory of the things that I've talked about here, this normal distribution curve. That at the top is kind of this random assortment of people, this random distribution, right? That they're all things considered, that people have different backgrounds, people have different perspectives, experiences, identities. They would still, regardless of these differences, still file themselves in a way that is represented visually by this normal distribution curve. So again, it's not playing for me. Hold on. Okay. So this is a visual of the Galton board. A long one. Okay, so again, all things considered equal, we're putting all the population back into this random distribution. And so this is the people. This is that random distribution. And just see where all the different little pellets fall. And even time and time again, they tend to fall in that very same pattern. And again, with all these different things that happen, we still have this distribution of people answering in very similar ways despite all of their differences. And not to say it's perfect, right? There's still some, but generally this is what this is what we have. And again, that was just a visual of what we really kind of look for in terms of statistics. And so now let's look at the different types of statistics and analyses that might be in your papers. And so the first one is called a t-test. And so it's also sometimes called a student's t-test. And this is used to compare to compare the means between two groups with t-values and p-values. And so a t-value is a number that shows the difference between the average mean of two groups and determines the significance due to the groups themselves, not necessarily random chance. And so this is where we have this null hypothesis come back into play. And so we can say that, with research, with statistics, you find this difference. So let's say this group 1 is smokers' weight, and this group is non-smokers' weight. There is difference. There's a mean of smokers' weight versus non-smokers' weight here. And to have a 95% confidence interval, essentially that you're 95% confident that the means differences between these two groups are from the group characteristics themselves and not just random results. And so with that, we find that, again, do smokers weigh differently than non-smokers? We find that I'm 95% confident that the this mean value between the weight of smokers versus non-smokers is due to the fact that one group smokes and one group doesn't. And so in order for that confidence to be exhibited in research, the t-value must be equal to plus or minus 1.97. And this really kind of gets at this confidence interval. And again, without going into too much nitty gritty, essentially what this is that I want to reject the null. And so I have to say with 95% confidence that the difference I found is due to these group differences. and not necessarily to random chance. And so with 95% confidence, this difference I found allows me to reject the null, which then supports the alternative hypotheses. And so it's kind of a related value. The p-value is the number that's used to show this significance that the population mean difference is due to the groups themselves. And I want to re-emphasize that this idea of significance actually does have a different meaning than maybe you and I kind of colloquially refer to it as. Statistical significance shows that this group difference is supported through statistical analyses. And so this is, again, due to this confidence interval that in order for something to be statistically significant, that means that with 95% confidence, you acknowledge and support that the means between two groups are different due to the group differences itself, due to the behavior, due to gender, due to the experimental exposure, right? And so the p-value is this number that's used to show this significance and by how much. Generally, we find that the p-value must be equal to or lower than 0.05, which if you're considering statistics, this is the 5% that basically allows you to reject the null. That, again, without getting into too nitty-gritty, the p-value is that percentage of acknowledging that maybe this is due to, happen chance that these groups differ just because of randomness, not necessarily due to their behaviors. And so generally we want the p-value to be smaller and smaller and smaller, but for the threshold of something to be considered statistically significant, that p-value must be lower than 0.05, so 5%. We might have some experiments that say 0.01% or 0.01, which denotes 1%, 0.001, which is 0.1%. But again, we want to find a p-value that is less than 0.05 to say that significance of what we found can be used to reject the null and support the alternative. So in Souliard, for the full sample, body appreciation was significantly different based on gender. So again, independent variable, gender, dependent variable, body appreciation. And so this is pretty much how it will be denoted in research. So let's go ahead and break these down. So what is the t-value? So the t-value is this number right here. So it's after the equal sign. So it's 4.47. And so when you look back at what confidence intervals are required for t-values to be significant, the t-value must be equal to or higher than plus or minus 1.96. And so because this t-value, 4.47, is higher than 1.96, it meets the 95% confidence interval threshold. Another way to check this confidence interval threshold to say that, I can, with 95% confidence, reject the null and accept the hypotheses or the alternative hypotheses, you can look at the p-value. And so the p-value is usually denoted after a comma, so p is less than 0.001. And so because the p is less than 0.001, and knowing that in order for something to be statistically significant, it has to be equal to or lower than 0.05, it very much meets the 95% confidence interval because this acknowledges that 0.1% of this representation might be due to random chance, but that is such the extremely small percentage. And so we can say with that confidence that what we did find was due to the characteristics themselves. And so as another example, looking at t-values, must be equal to or larger than 1.96. For this one, it is 4.47. So yes, it is statistically significant. We also see this in the p-value. So the p-value must be equal to or lower 0.05. In this case, it is 0.001, which is very small, much smaller than the necessary threshold required for statistical significance. Another thing you'll find in this representation are the degrees of freedom. So the degrees of freedom, if you remember all the way from when we talked about standard deviation, that n-1, that is the degrees of freedom. Essentially, without getting into too much nitty-gritty, are the total number of participants minus 1. And so the total number of participants for this part of the research was 252 minus 1. The degrees of freedom is 251, and that'll be denoted in the parentheses after the t. So again, really focusing on the t-value after the equal sign, p-value after the less than or greater than or equal to sign. All right. Then we have ANOVA. So when we had t-tests, this is comparing two groups, two means. For ANOVA, this is where we compare 3 or more means. And so when you are using a categorical independent variable, this is called a one-way, whereas 2 categorical independent variables is a two-way ANOVA. And before we really get into, or for the purposes of the class, that's not necessary to really know the difference. But just generally what we'll find is that ANOVA assesses the differences between 3 or more groups, and as a consequence, 3 or more means. And so the F value is how you know this is an ANOVA versus a t-test. The F value is the number that shows the difference between the average of the 3 or more groups and determines the statistical significant difference is due to the groups themselves, not random chance. It gets at the same stuff, but because there's more groups, there's more means to do analyses, it becomes a bit more complicated in the sense that it's not as clear cut to know when the F value itself is significant. So you have to look at the P value to see that significance. But generally, you need to have an F value larger than 1, and it's a bit more complicated to find the F value, and that'll come when the time comes for you. So for ANOVA, 3 or more groups, 3 or more means being compared, you need to look at the P value to find if that group difference is due to the characteristics of the groups themselves. And so this is the number that, again, we use to show significance in a population mean difference that's due to the characteristics of the groups that you're really assessing. And so to have a 95% confidence interval, meaning that you're 95% confidence that the mean differences between the 3 or more groups is due to the group characteristics themselves, the p-value must be equal to or lower than 0.05. And so for this example, they did compare 3 or more groups in talking about athlete status, and it was like full-time, part-time, no time at all. But anyway, the results showed a significant main effect on athlete status. And so this is where we know, hey, this is an ANOVA. They're comparing 3 or more things, F value. So the F value is 13.08, so it's above 1, so it could be statistically significant, but I need to double check and make sure that with the P value, it is. And so what is the F value? Just like the T value, it'll be after this F equal sign, so it is 13.8. The P value is, P is less than 0.001, and so it is extremely statistically significant. It is significantly less than the 0.05 that is necessary for confidence interval. And so some of the things that you will find with ANOVAs, very similarly in the format of a t-test, you'll have the F value, which is after the equal sign, and the P value, which is after the comma after the F value. And generally, we find that P is less than a single number or a value. Sometimes there'll be equal signs and sometimes they'll be greater than, but generally if you're, putting things out to the world, you want to be confident in what you found is actually helpful and supporting of your hypotheses. And so that's why the P value is less than 0.001. That being said, this is not necessarily the best example of an ANOVA. And again, for the purposes of your paper 4, I'm really just doing this as an exposure for you all to just be familiar with some of these things and not necessarily to be critical of the research that you find. But if you find something like this, it's just important to know that for F values, as opposed to T values, there are 2 numbers inside the parentheses. The first number is the number of groups. And so just like the degrees of freedom, it'll be the number of groups minus 1. And so for this purpose, it's 2 minus 1 equals 1. That's why this 1 is here. And that's why I don't necessarily like that they used an ANOVA to use the statistical analyses, because it's only comparing 2 groups, which you could easily have just done that with a T value. And so it's a bit confusing as to why they actually did it this way. But again, with more exposure, you start to think a bit more critically about your peers doing research. And then relatedly, the second value in the parentheses are the degrees of freedom. So for this experiment in particular, there were only 250 participants. So minus 1, 249 is what we get here. So again, what you're really looking at are the values after the equal sign and the value after the P. And so finally, this is the last bit of statistical analysis that you might find. And these are called correlations. So like I said earlier, correlation does not equal causation, but it can be insightful in eliciting different types of consequential experiments. And so correlations are used to see how the effect on 1 or 2 variables are on each other. And so the correlation coefficient is the number that determines the strength and direction of that correlation, in the sense that if you increase one, will it increase or decrease another? And so correlations have to exist on a spectrum. There can't just be yes or no, 1 or 0. It has to be on a numerical spectrum. And so these correlation values themselves fall in a range from 0 to positive or -1. And all correlation values should be in a decimal. So again, the variables themselves have to exist on a spectrum that can contribute to the decimal value talked about earlier. So let's talk about these correlational coefficients. The correlational value, again, determines the direction and the strength of said correlation. And so a 0 correlation coefficient indicates that there's absolutely no correlation between two variables. It's completely random. They don't have any relationship on the other. And so we see that kind of represented here, that, we have one variable existing on a spectrum and then another variable existing on a spectrum. They don't have any relationship. They don't have one effect on the other at all. Very rarely do we ever see this. Even if stuff is not even related to each other, we still find that there's at least some sort of decimal represented here. So very rarely do we have a 0 correlation. On the opposite side of that spectrum, plus or minus 1 as an integer represents a perfect correlation between these two variables. And so this is represented here in a -1 correlation or a +1 correlation. So to kind of give you some understanding of what positive and negative is that for negative, as one integer increases, the other decreases. Similarly, as one decreases, another increases. So we kind of see that they have a negative relationship. Flip side of that, a positive correlation, as one increases, the other increases, right? This steady incline. Similarly, as one decreases, the other decreases, And so that's what positive and negative correlations mean. And so when you consider a small or large coefficient, this is where it gets a bit more nuanced. And generally we find that a correlation is not as strong if that decimal exists between 0.000001, but for the sake of this class, 0.01, and 0.5. A larger coefficient, which the correlation is very strong, in which one variable has a really impactful influence on another, is when that variable coefficient is between 0.51 and 1. And so we want to have decimals as our coefficient correlations. We do not want to have zeros, and we do not want to have 1 or -1, because essentially what -1 and 1 say is that, they don't really tell us anything. They say that, both of these things exist in the same way, they behave in the same way, and so there aren't that many differences that can be experimented on. There's no insight here. And so just again, to reiterate, these characteristics do not guarantee significant difference between these two variables, even if they have a strong relationship, in the sense that additional statistical analyses are determined by sample size, standard deviation, variance, and means, and you don't need to know how to derive those things yet. You might in your high-level statistics classes, but the only way to see significance for correlation is with a p-value, usually denoted with asterisks. So to give you an example of what this would look like in a paper, this table showcases the correlation of student athletes' body appreciation, functionality appreciation, flow state, sport confidence, and subjective performance. So 5 different surveys are being used here for various things. And so on average, it compares the average between these things and basically says, if body appreciation goes in one direction, how does that affect functionality appreciation? Similarly, if sport confidence is something that we're looking at, how does sport confidence affect body appreciation? So these are like comparative values within the survey and methodology that's being used. And so this is a visual representation for correlations. They're typically done with a chart. And so we're going to really spend some time looking at this chart, making sense of it. And so let's go ahead and get into it. So the numerical values at the top correlate to the numerical values on the left side. It would be relatively redundant to put body appreciation here, functionality, flow state, sport confidence, and subjective. And so for the sake of streamlining this experiment and this visual, just know that the 1 is talking about body appreciation. The 2 is talking about functionality appreciation. The 3 is talking about flow state. So flow state is in this column here. 4 is talking about sport confidence. And you'll notice that 5 doesn't exist on this top bar. And the reason why is because when you compare this one value to the other 4, you see that represented here. And so relatedly, when you have 2 of the same variables, you don't have a value because it would give you a perfect 1, right? As one goes up, the other goes up because it's the exact same survey. And so this is, again, we want to find the relationship between 2 different values, 2 different surveys. And so if we wanted to, let's go ahead and start with this one. What is the correlation coefficient between BAS2 and FAS? And so sometimes they'll just use the acronyms of these surveys, but they'll have them in parentheses right next to what they mean. And so the BAS2 is talking about body appreciation, and the FAS is talking about functionality appreciation. So again, 2 things, 2 values that the researchers are looking at in terms of how it affects student athletes. And so the values on average are found, and they're compared between these 2 variables. And so again, what is the correlation coefficient between BAS and FAS? And so as we know, BAS is this 1, FAS is this 2. So let's start 1. Okay, BAS to FAS. So I start at 1 and I go to 2. There's no value here. But I know that these 2 things can be flipped. So I go to, okay, let's go to 2 first. 2, which is FAS, and see how it affects BAS2, which is 1. So that's this value here. This is how you read a correlation chart. And so you have FAS and BAS correlation value here. So this is 0.64. So what is the correlation coefficient between BAS and FAS? It is 0.64. Is it positive or negative? This is a positive, meaning that as one goes up, the other goes up as well. Is it a small, moderate, or large coefficient value? It is relatively large. I would say that this is a larger, more strong relationship between BAS and FAS, meaning that generally we find that as BAS goes up, FAS will go up at along the same rate as BAS, but not identical, because if it was identical, then this value would be an integer 1. Is it significant? So remember, the only way to find significance between these 2 variables is by looking at the asterisks and the asterisk associated p-value. So p-value is still consistent through every single statistical analysis. You need to have a p-value equal to or less than 0.05. And so this value in particular has 3 asterisks. And so when I look down at the note, 1 asterisk means a p-value of less than 0.05. 2 asterisks means a p-value of less than 0.01, and 3 asterisks means a p-value of less than 0.001. And so does 6.4 with 3 asterisks denote significance? Very much so. It is a very statistically significant correlation. And so we find that this relationship between BAS and FAS is due to the characteristics of these values themselves, not necessarily to random chance. And so let's go ahead and try this second example. So what is the correlation coefficient between BAS2 and SPQ? So SPQ is all the way down here at 5. So again, BAS2 is denoted by this 1. And so if we go down, if we wanted to start here first, we'll go all the way down to number 5, right? We see that this is how it is represented. Okay, so what is the correlation coefficient between BAS2, which is again 1, and SPQ, which is all the way down to 5? It is 0.12. 0.12, is this positive or negative? It is positive. If it was negative, it would have a negative sign, a minus sign in front of it. Is it small, moderate, or large? This is a small correlation coefficient, meaning that the relationship is not necessarily strong between SPQ and BAS. So don't really have much of a relationship there. Is it significant? There are no asterisks following, so that means it is not statistically significant. That even though there is a relationship, it's not due to the characteristics of these values themselves. And then finally, we have what is the correlation coefficient between SPQ, number 5, and TSCI, which is sport confidence, number 4. And so again, if we were to go, and let's start with TSI, right? We know that they have similar relationships. One can go first, the other can go first. It doesn't really matter. And so we start at 4, we go all the way over. There's no 5 to compare to. So then we have to start with 5 first. Okay, so we have SPQ, go all the way over to our 4 column, because as we know, the 4 at the top is the same 4 that's represented here. And so we go all the way over to this 4. What is this value? 0.30. That is the correlation coefficient between SPQ and TSCI. Is it positive or negative? This is a positive correlation, meaning as one goes up, the other goes up. As one goes down, the other goes down. Is it small, moderate, or large? I would say this is small to moderate. There is a slight relationship here. Is it statistically significant? The reason why I bring this one up is because even though the relationship isn't necessarily strong, it still has statistical backing that says that, yes, even though the relationship isn't strong, it is statistically significant in showing that with 95% confidence, this, although small relationship that exists between these two variables is due to the variable characteristics themselves, not necessarily just due to random chance. And so even though a correlation coefficient can be small or moderate, it can still be statistically significant in what you find. And so again, this has 2 asterisks, so when you go down to the note, 1 asterisk is a p-value of less than 0.05, 2 is a p-value of less than 0.01, and 3 is a p-value less than 0.001. And so again, all of these asterisks do acknowledge at least the 95% confidence interval, but it's kind of a weird space where you want to acknowledge these others as well because it provides more confidence to reject the null and accept the alternative. And so for this one, there's 2 asterisks, and so you can say with 99% confidence that this relationship is due to the variable's characteristics themselves and not just due to random chance. So again, you might find that this is an example. If you have any questions with this, please let me know. Ask questions. I understand that this can be very new and potentially overwhelming. And so finally, we're going to finish up with the discussion component. So again, why this is important. Did the researcher find what they were looking for? What conclusions did they make about the data that they found? How does this paper contribute or continue the education of their respective field? And so very similarly to the introduction, in which it's a suggestion to discuss the results, compare it to that greater body of work that was discussed in the beginning, suggestions for future studies, disclosing limitations, and making conclusions. And so let's break down really what each of these components are. So the first thing they're going to do is discuss why they believe they accept the results. And again, this comes down to statistical analysis. They would say something like, in X experiment, in X comparison, we found that the p-value is less than 0.05, so we can reject the null hypothesis and support the alternative and saying that this hypothesis was factual in this experiment or something like that. They also can compare the results to previous research. Maybe what they found didn't agree with their hypotheses, or maybe what they found did not kind of agree with what they had what had been done before them. And so they would compare the results to previous research. If it was similar, if it was different, that would be something that they would discuss. The third thing is that they would make suggestions for future studies. And so, based on what we found, we want to make XYZ changes because of the data that we found to serve said populations. Limitations of the study is a bit interesting. It is necessary for all experiments, and all academic papers have to have some sort of limitations discussion in their conclusions or discussion sections, because this acknowledges that, although we do our best to maintain an accurate representation of a general larger population, there are some things that are out of our control. And so limitations can be age, right? We find that generally populations or sample sizes in these research articles are college students, and that isn't necessarily representative of an entire population. Another thing that they might know is gender. Generally, we find that women are more inclined to be research participants than men, And so they have to acknowledge that. Although what we found is statistically significant, we found that we had a higher percentage of women to men than would be representative of the general population. And so even though they have these limitations, that doesn't necessarily mean that what they found isn't helpful or impactful. It's just important to acknowledge these limitations and maybe use that as suggestions for the future. So if you were to say, we had a lot of women taking this study, we implore future researchers to really see how this would affect men or would affect younger populations or would affect non-athletes or something like that. And then finally, some papers have separate conclusion sections, but some do incorporate it into the discussion section overall. But it really just describes this take-home message to the reader based on the variable study. What was important from this work and why was this work important? And so this is represented in a lot less of a breakdown like we see with methods and results. It's pretty much just like all writing, and you really have to do the reading itself to find where these different points are being brought up. And so for the first part, we have restating the purpose statement. Why did we do this? Accepting the results here and here. And while they're accepting or rejecting their results, they'll compare it to previous research as to why they accept or why they reject it. Suggestions for future studies, limitations, and so it usually says this study is not without limitations. First, given the cross-sectional design of the present study, the results do not provide evidence for causality, which reduces the amount of applications can be drawn. They acknowledge that that correlations, as seen here, does not equal causation. And so that's important to acknowledge, and that's okay. And then finally, the conclusion. So like I said, there's not really like a limitation section, although sometimes they might have that. Generally, you'll just have to read this all and figure out those breaks and those emphases as you go. And so we read a paper, we like this paper, and now we're going to talk about it in our paper 4. And so this is how we write a reference in APA format. And so if you go to paper 4, and I think all of the other papers before this had a link to Purdue OWL, they're very helpful in how to structure things in APA format, but I wanted to give you a bit more of an in-depth lesson on how to do this yourself. That being said, do not use like bibliography.com. They don't do a good job formatting things in APA format because it is very specific. And I'll explain why. And so again, the first thing that you're going to do is how to write a reference. And this is in your references page. So at the end of paper 4, you need to have a reference page of the one article that you chose to showcase that you know how to do this. And so what you'll do is you'll have the last name, first initial, period, second initial, period, of all of the authors listed in the order of the paper, not in alphabetical order. And the reason why is because, as contrast to MLA, APA format purposefully puts authors in certain orders as recognition for their contribution to the paper. So usually the first author did the most work, did the most research, did the experiment. Second person did the second most work, second most credit, blah, 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 all the way down. The last person is where it gets a bit tricky. Some papers, the last person did the least amount of work. In some papers, the last person is maybe a hot shot in the field that maybe had something to do with it, but they kind of just include that person as maybe to honor them, to honor their contributions, or to just basically say like, look at this flashy name that's attached to my paper. But for all intents and purposes, do list the authors in the order that is presented in the title of the research article. And it's important to list them in order, separated by commas and followed by a period. So to kind of illustrate this point, we have Abbott, last name, comma, first initial, period, second initial, period, comma, ampersand. We'll get into kind of the difference between using and ampersand in a moment. Barber, last name, period, or comma, B, period. So we have to have a period at the end of the names, all in regular text, non-italics, non-underlined, non-bold. Then you have the year of the publication in parentheses followed by a period. So for this one, it's 2010 in parentheses, period. The title of the paper with only the first word capitalized, or if there are mid-title punctuations like this colon here, that would be the only other time that you would have a uppercase letter following that, or if it's a proper noun. So embodied image, gender differences in functional and aesthetic body image among Australian adolescents. So the 3 words here that are capitalized, the first word, yes, the first word is always capitalized. The second word is gender. And the reason why is because this kind of acts like a period, right? So it's still like the first letter of a new sentence. And so this is, this semicolon are kind of the only, or maybe a period, are kind of the only things that would elicit a second word outside of a proper noun being capitalized. And then the third word that is capitalized is Australian, because Australia is a proper noun. You have to capitalize that first letter. Everything else is lowercase, which again, if we're going to find this in a moment, titles usually have all uppercase for all of their words. That is different. You do not do that in a reference and APA format. Then the next thing that you have, so after you have the title, there's a period at the end, then you have the journal name with their matching their formatting. So it matches the format in terms of all or none of the words are capitalized or not. So just do it exactly how the journal does it. And it's in italics followed by a comma. So this came from the journal body image, and I know that because it's in italics. The next thing after the comma is the journal issue. And so you'll just include the number in italics as well, as followed by a comma. And then finally, you have page numbers, not in italics, in numeral format followed by a period. So I don't want to see P or PP period or page. It's literally journal and journal issue in italics, then non-italics, page numbers, just the numbers themselves. After that, you include the period, and then after the period, you have a hyperlink of the DOI webpage of the paper, and do not break it between lines. And so this is different than the hyperlink of the article itself. DOI is actually challenging to find, so if you need help with that, please let me know. Sometimes they'll have it kind of in the article information section, but do know that if you include the hyperlink of the www.body image journal / whatever, I will dock points. That is not the DOI that is necessary for a reference in APA. And again, it is different, and I can help you find that if you need it. Additionally, you have to indent after the first line. So you'll see here that this is flush with the references. Everything after that first line is pushed inwards. And again, I can show you how to do this in person. It's a bit finicky, but again, this is the standard for all APA papers. So anything that you do in kinesiology, anything in bio, anything in psych, it follows this format. And so let's go ahead and do this together. So using the Souliard paper still, this is the front page where you're able to find pretty much all of the information necessary for a reference. And so again, the title of the paper, usually up here. This one is interesting because it did have everything after this first word lowercase, which is again part of the reference. Then you have the authors listed right underneath. Then you have the journal title, body image here. Journal issue, which is kind of at the top. You'll find that it's like body image 28. The page range is 93 to 100. The year of publication 2019. And the DOI hyperlink is sometimes at the bottom, and it's http://doi.org followed by this number. So this is the DOI, not the website that you get this from or the PDF link that you get this from. It is the DOI hyperlink that is provided by the journal. So we have all these different things. And so we have the title, we have the authors, and again, the authors are usually presented by their full name, but because it's a reference, we have to convert that into their last name, comma, first initial period, second initial period, comma, right? In the same order that's presented. We just have to convert it a little bit to make it fit APA formatting. DOI here, body image 28, 2019, 93, 100. So all these different things, we have the authors first, then the year, title, journal, issue, page number, DOI. All these things. So this is what you would include in your reference citation when you turn in paper 4. Additionally, you need to have in-text citations. And I know that you're only doing one paper, so you only need one in-text citation, but I want you to do it to show me that you know how to do these things in the future. So there are two different ways in which you can do in-text citations. And for this example in particular, the use of et al. Is very common. And so for a paper with 3 or more authors, as this one was, you need to use et al. For all authors after the first author and the year. So et al., just to kind of give you some background as to what that means, is an abbreviation from the Latin term et alia, which means and others. And so this would mean Souliard and others 2019. So this is how it would look because Souliard has 3 or more authors. So you would do Souliard et al. Parentheses 2019, or if you wanted to, again, paraphrase something and have everything in the parentheses, it would be Souliard et al. Period, comma, 2019. So the year at minimum has to be in the parentheses, but you can include the authors in that as well. So this is how it would look. For a paper with one author only, which is so incredibly rare, it's just the one author and the year. So for that example, it would be Souliard, parentheses, 2019, end parentheses, or Souliard, comma, 2019, in parentheses as well. For papers with 2 authors, it's the first and second author's last name only in the paper order divided by an ampersand. And so just for the, let's just say for all intents and purposes, just use ampersands instead of using and. And so this would be, again, using the ampersand here for the reference citation. There is a difference, but it's so nuanced. So for the purposes of this class, just use the ampersand, which is, again, this symbol right here. That's what it's called, an ampersand. And that's how you would reference 2 or more authors. And so again, for 2 authors, which is common, you'll have Souliard, ampersand, Kaufman, 2019, or parentheses, Souliard and Kaufman, comma, 2019, in parentheses as well. And again, this is just an example. The actual paper has 4 authors, or actually 5 authors. And, but again, for the illustrational purposes of this in-text citation, the difference between 3 or more authors, 1 author, and 2 authors are listed here. Okay, so as we finished up this lecture, I want us to spend a lot of time reflecting and asking me questions about things that you have. I wish that this was an in-class lecture, but I think that it is important if you have questions to go back to those places that maybe you didn't know what the heck was going on. Write down the questions that you have to talk about what you don't have answers to or what you're confused about. And so thinking about the course material, what information have you learned that assisted your understanding of this article? Once you get to your article, I want you to reflect on it. This is actually the part 5 of your paper. Which parts of the study were harder to understand, and where do you feel like you need to improve your understanding in this field? So again, you can ask me questions, but this is where, again, I don't want to hold your hand. This is something that if it's something of the formatting of whatever, feel free to ask. I'm a resource to all of you, but I want you to try to do your own digging first. And again, knowing where the proper resources are important because maybe what you find isn't necessarily truth. But again, try to figure things out. Try to be independent in this term of research. But so now we're going to practice, and this is where we practice, ask questions. So again, we spent the entire class talking about one article of the 3 that I assigned to you. So now that we did this together, you are able to look at these 2 other articles and make sure that you understand them. Although you can't use these papers for paper 4, you can use them as practice runs to ensure you can answer all of the questions on the paper 4 prompt. Additionally, you're welcome to ask me specific questions about either of these 2 articles to assist in your learning. And again, I really recommend breaking it down using a highlighter or a brain map or a flow chart, and just get this paper information, the paper questions out of your head and onto some notes. And again, ask questions. I know this is brand new to maybe a lot of us. So again, after you do your own little research and you're like, I really need Asia's help, you're always welcome to come and ask me. Additionally, I will include questions about these papers on your quiz 4. So I highly recommend you do this time and take this time to sit with the articles, understand them for content, as well as how to find certain things, right? So in addition, like if I ask like how how many participants were in this paper. You should be able to go to the method section, know that n equals whatever, and then that would be the answer that I'm looking for, right, as an example. Additionally, I will be including a brand new academic paper on the final, so I really recommend you practice your academic reading skills in order to have success on the final in the future. Okay, so we're almost done with lecture. But I do want to kind of break down what's expected of you for paper 4. So again, this assignment is designed to be an introduction to analyzing research one article in the kin field. You'll be choosing one peer-reviewed research article from the field of kin on a topic of your choice. Again, it cannot be magazine articles or blog websites. You can access the article online, but do not use a regular website or a blog or social media as your source. It must be peer-reviewed from a reputable kinesiology journal. Please use a library search engine or Google Scholar. That will usually steer you in the right direction, but do your due diligence and make sure that that journal is legit. Ask me if you want me to make sure that that journal is legit, but as long as it's peer-reviewed and it comes from a reputable place, that's usually fine. It must have been published between 2000 and 2023. Like I said, research can become outdated, so it's important to keep up with the most current knowledge that we can about your respective subject. You will be turning in a PDF copy of the article and a Word document or a PDF with the following questions answered. So again, you're turning in 2 separate files. You're turning in your article, so you have to make sure that you can download it to your computer and re-upload it to Canvas. And you're turning in your reflection paper, which we'll get into in a moment. 2 things have to be turned in to get full credit. With that, you will only be permitted to write a maximum of 2 pages. So I'm upping the page amount just because the prompt asks you for significantly more than our previous papers have done. This will be a demonstration for you to paraphrase research accurately and concisely. If you go over, I will dock you points. I do not want to reread the entire research article in your paper, so that is why it is a maximum of 2 pages. Again, if you can write concisely for 1 and 1.5 pages, that's fine, as long as you hit all the points in the prompt right here. However long you want it, or however short you want it to be, is fine. But I highly recommend taking the full 2 pages. Don't go over. And again, once you find an article that interests you, you'll read the article and address the following points below. So there's 6 things that you need to have done to get full points for this assignment. The first is you're going to introduce and discuss the introduction. What did the literature review talk about? What questions did the researchers have? What do they expect to happen and what were their hypotheses, right? Then you're going to tell me about the methods. What kinds of studies were performed? Was it experimental, correlational, descriptive? It better not be descriptive. If I have anyone do descriptive research, I will give you a deduction. Please find experimental research. It'll make this project so much easier if you find something that's experimental. Was the data qualitative or quantitative? Who were the participants? What did they do? What type of data or measurement did the researchers collect via the methods? And what were the methods or measurements used? Third thing is you're going to tell me what the results were. Discuss the results. What did they find? What were the outcomes of the study? Were the data significant? What were the statistical analyses they used? Did they include images, graphs, or charts to help explain their findings? Fourth thing is that you're going to discuss the discussion. Did the researchers find what they were looking for? What conclusions did they make? How does this paper help continue the education of their respective field? And then finally, reflect on your understanding. So for these 4 points, I want you to do as best you can to understand what they're saying. But this 5th point is necessary, 1, for you to get full credit, but 2, to tell me and to allow yourself to reflect on maybe what you didn't understand or what you think that you need to do more of to have a better understanding of these things in the future. And so thinking about our course material and lecture, what information have you learned in this class that assisted in your understanding? Which parts of the study were harder to understand? And where do you feel like you need to improve your understanding of this field? And then finally, you need to have a full reference page of the article at the end of your writing. So these 5 points are included in the 2 pages. This will be a final 3rd page. And so when I talked about earlier, a max of 2 pages, this is of writing, because the 3rd page will be your reference page. So again, these 5 things should be discussed relatively evenly. a lot of us are going to kind of maybe devolve a lot into the results, thinking that if they talk a lot about these things, that it's going to make more sense and that it's going to do all these things. And that's not what I want. All 5 of these writing parts, I want to be spent equally. I want you to spend equal time on intro, to methods, to results, to discussion, to understanding, right? All of these things are just as important as the other. So that's why I expect to have very similar length paragraphs for each of these 5 writing points. Finally, late assignments will only be accepted for 24 hours after the due date for up to half credit. After 24 hours, they'll be past due and you'll be getting a 0. That being said, I pushed the date back to December 1st. I understand that this is going to be brand new to a lot of us, so I want to spend a lot of time answering questions and working on formatting, and to give you ample time to really kind of figure out what you like, what you don't like, and how we can go forward from here. So the grading criteria is the submission of the paper. Again, max 2 pages of writing. Please have it be 3 pages worth of stuff, with the 3rd page being the reference page, and the article. Both of these things need to be included, both of them. The second thing is that you're going to sufficiently answer questions 1 through 5. So again, writing points 1 through 5, 15 points for 3 points each. And I want all of these things to be equal. All of these things are equally as important to the other. So intro, methods, results, discussions, and reflection. All of these things must be sufficiently answered equally to each other. And then finally, grammar and formatting, and correct APA citation of the article in text and on the reference page. So these are my grading criteria for this paper, for a total of 25 points. So again, let me know if you have any questions about this stuff. I understand it's a lot, and this was a long lecture, even for me as I'm sitting here doing it. But I hope you all have a great Veterans Day. Enjoy your long weekend. Do know that your quiz is going to be due that Friday, the 10th at midnight. Next week, we are going to be doing our biomechanics lecture with Dr. Zeff, who is a brand new faculty professor here at Cal State. Please read chapter 8. And the week after will be Thanksgiving break. So this is kind of our weird jump before we really get into the end of the semester. But again, let me know if you have any questions about this stuff. And I really look forward to seeing you all next week for biomechanics. All right, folks, have a great week. Bye.